two primary outcomes of this feature. One, prior to 9.6, if the WAN side IP changes, your manual route policies are lost. They just get removed by the orchestrator. We don't even tell you about it. We just remove them. After you upgrade to 9.6, even if that WAN side IP changes or something changes with the WAN side interface, your manual route policies will persist. They will remain in effect, so that when the IP is restored, the manual route policy will continue to operate. The second primary outcome of this project is, and I actually think this one's more important personally, is that if a WAN side IP changes, local breakout pass-through tunnels, SSE tunnels, third-party tunnels, and fabric tunnels must self-heal without intervention from the orchestrator. And that's exactly what happens. So prior to 9.6, you would get convergence in the range of 2 to 15 minutes sometimes for that orchestrator to reach back in there and reconfigure local breakout, pass through tunnels, change the source IP, remake the tunnel, all that stuff. That takes a long time. After you upgrade to 9.6, it'll take about 15 seconds. Always. It'll always take 15, maybe 20 seconds at the most. Prior to 9.6.0, the EdgeConnect management layer is using local breakout, and it's going over INET A to reach the orchestrator. INET A's IP changes for whatever reason, right? The orchestrator WebSocket will get interrupted because you literally just changed the IP address of the socket that the orchestrator was riding over. Now, internally, EdgeConnect reconnect through the portal to the orchestrator quickly, and it happens like the EdgeConnect, even though it had its orchestrator socket disrupted, and you're going to have bad local IP in the configuration for a while, it will eventually get a hold of the orchestrator, and the orchestrator will fix it, and then INET A will become available again. But it can take a while. So after upgrade to 9.6.0, let's look at the same situation. Step one, again, same thing. The EdgeConnect management layer and all the users at the branch, by the way, are using local breakout to get to the orchestrator through INET A. INET A's IP changes. So the orchestrator is interrupted, but and the users are disconnected momentarily. Of course, necessarily they have to be. Their source IP changed, their NAT source IP changed. But the local EdgeConnect will immediately repair all of the tunnel pass-through tunnel artifacts. It will fix local breakout, Zscaler, IPSLAs. It'll do all of this stuff. And what you'll get is what you see on the right over here, about 20 seconds. Even if the EdgeConnect can't reach the orchestrator, it will self-heal and it will correct and fix these things for you. Okay, additional notes. This actually has the side effect of reducing orchestrator load because the orchestrator has to do less. On the hub side, we lose some of the advantage. The Zscaler or the SSE third-party tunnels will auto-heal, but the fabric tunnels will not. For branch deployments, of course, we use NAT Discovery and some other stuff that makes the branch auto-heal. Just be aware that if the hub side IP changes, it won't recover quite as quickly. As a part of this feature, we implemented a new setting for controlling the behavior of the DORA process. So in the system template, if you check this box, restart DHCP client when next hop is unreachable. So this is unchecked by default. I think if you're a Starlink Maritime customer, this is probably going to be necessary. Or if you're having trouble, DHCP IP changes and the box doesn't recover or doesn't get the new IP or whatever, toggle this checkbox